Hello, welcome everyone to lecture number 27 of Fundamentals of Computing. This lecture is on data transmission mode. The topics that I am going to cover in this lecture are the different type of transmission modes, that is the simplex, half duplex, full duplex, parallel, serial, synchronous and asynchronous transmission mode. So let's first start with what is transmission mode. From this diagram you see there is one sender and one receiver. Sender sends the data and receiver receives it. So this is the transmission of a data, means a data is transferred from a sender end A and receiver B receive it. But whereas in this, the B becomes a sender and A becomes the receiver. So what exactly is the transmission mode? It defines how data is sent and received between the sender and receiver, or you can say between the devices. Transmission of data can be categorized based on the direction of a data flow. On the basis of what? We have the simplex, half duplex and full duplex. The number of bits that has to be transferred simultaneously, on the basis of that we have the serial or the parallel transmission mode. And finally, the synchronization between sender and receivers. So according to that we have the synchronous and asynchronous transmission mode. This diagram represents different transmission modes. Depending on the direction of a data flow, we have a simplex, half duplex and full duplex. Depending upon the number of bits transferred simultaneously, it is serial or parallel. Depending upon the synchronization between the sender and receiver, it may be synchronous or asynchronous. So let's first start with the transmission mode, where we consider the direction of flow of data. So it may be simplex, half duplex and full duplex. Let's go into the detail of each of them. First one is the simplex mode. From the diagram you see there is a one CPU, keyboard and monitor. So direction of flow is what? The data is taken from the keyboard, sent to the CPU, and from the CPU it is sent to the monitor. This represents the simple transmission. So what is there in the simplex mode? The communication is unidirectional. Unidirectional means what? Data flows in only one direction, means from the sending device to the receiving device, but not in the backward. So it means what? Only one of the two devices on a link can transmit, the other can only receive. There is no mechanism for information to be transmitted back to the sender. So that's why we say that it is a communication is a unidirectional. Example, the computer can send message to the printer, but the printer need not send data or message to the computer. The simplex mode can use the entire capacity of the channel to send data in one direction. Example, keyboard, traditional monitors and TV broadcasting. These are the example of simplex mode. This type of transmission is similar to your one-way traffic. One-way traffic means what? Data flows from only in one direction only. The other direction is not allowed. It goes from here to here, only in this direction. That back direction is not possible. This is the easiest and most reliable mode of communication and is the most cost effective mode because it only requires one communication channel. It has a disadvantage. There is no way to verify if the transmitted data has been received correctly. So that was all about the simplex mode. Next one is a half duplex mode. From a diagram you see in the first case A is a sender which is sending a data to the B and B is receiving the data. Here the B now becomes the sender and A becomes the receiver. So it means what? A can send a data at a time and in this case B can send a data to A. But in the case of a simplex only it has been sent from A to B, not from B to A. But it is a half duplex. Why it is a half duplex? Or you can say semi duplex because there is only one communication channel or a wire or a cable to carry that, and both the devices can either sender or receiver, but only one can transmit data at a given time. That's why it is a half duplex. At a time, if this is a sender, then this becomes a receiver. On the other time, if B becomes a sender, then A becomes the receiver. It is what? It is like a one-lane bridge. What happens in the one-lane bridge? Vehicles can come from both the directions, but not at the same time. It is used in a web browsing where user sends a request to download a particular web page, and then that page is downloaded and displayed to the user. Best example is a walkie-talkie. If one person is saying something, so another will receive it. When this person says something, then this will receive it. So it may be at one time this becomes sender, this becomes receiver, at other time this becomes a sender and this becomes the receiver. Another example is the citizen band radios. So because of that, it is not a complicated technology. It allows for bidirectional communication, which is useful in situations where devices need to send and receive data. It has some disadvantages also. Disadvantages are that it has a limited throughput. Why? Because since data can only be sent one way at a time, there is a need for coordination between transmitting and receiving devices that makes it complicate the communication process. So this is all about the half duplex. Next one is the full duplex mode. In the case of a full duplex mode, from the diagram you see that the transmission is allowed in both the directions at the same time. The PC can transmit the data to the terminal, terminal can transmit it to the PC. That's why its name is full duplex. So here data flows in both the directions simultaneously. Each end can send and receive data signals at the same time. The number of communications channels can either be 1 or 2. If there is a 2 channels, then one can use for sending, whereas other can be used for receiving. So if these are the 2 channels, so one can be used for sending, another can be used for the receiving signals or data. In case of one communication channel, what will happen? The bandwidth of the channel is divided into 2 for each direction of data transmission. So it's like a two-lane bridge where vehicles can simultaneously travel in both the directions but only in their respective lanes. Example is a telephone system where both the caller and receiver can talk at the same time. It has some disadvantages or limitations also. Full duplex machines often require far more power than their half duplex counterparts. Full duplex communication is more susceptible to errors and data collisions when improperly managed. So this was all about the full duplex mode. So we have gone through the simple, that is a simplex mode, half duplex and the full duplex. Next categorization is based on the number of bits transferred simultaneously. So according to that, it may be serial or parallel. From diagram you see that in the case of a serial, there is only one channel through which the data is transferred. This is the most significant bit and this is the least significant bit. It has been transmitted from this D1 to D0. Whereas in the case of a parallel transmission, for each bit we have the channels, right from the most significant bit to the least significant bit. So what are the differences between serial and parallel transmission? Obviously, data is sent one bit at a time over the transmission channel in the case of serial transmission, whereas n bits are simultaneously transmitted over the communication channel in the parallel transmission that we have seen in the diagram. A single communication link is used to transfer data from one end to another because single bit is transferred over a transmission channel, whereas in the case of a parallel, multiple parallel links are used to transmit the data, and because of that, serial transmission is cost efficient, whereas parallel transmission is not cost efficient. Serial transmission is slow in comparison of parallel transmission. Why? Because it's in one bit at a time over a transmission channel. Parallel transmission is fast in comparison to serial. Why? Because it transmits n bits simultaneously over the transmission channel. Serial transmission is used for long distance and parallel transmission is used for short distance. The circuit used in the serial transmission is simple, whereas the circle used in parallel transmission is complex. Serial transmission is a full duplex as sender can send as well as receive the data, whereas parallel transmission is a half duplex. Why? Because the data is either sent or received. Serial transmission is reliable and straightforward, whereas parallel transmission is unreliable and complicated. Serial transmission requires few wires, reducing bulk, whereas parallel transmission requires more wires and increasing the bulk. So this was all about the serial and parallel transmission. Next categorization is the synchronous and asynchronous data transmission mode. So here you see that the data has been transmitted from sender to receiver as a what? As a bits, block of bits. In the case of a asynchronous, there is a start bit and stop bit which is associated with this blocks, which indicates that start means what? Yes, sender sends the indication that yes, I have started sending the data bits, and stop bits indicates what? Here you have to stop. So let's see what is the difference between the synchronous and asynchronous data transmission. In the case of synchronous transmissions, sender and receiver are synchronized with each other using a clock. and the characters or bytes are grouped together to form a data block. Yes, this is what? This is the data block. And then a header and trailer are added to the data block to form a frame. It means what? With each frame, the header and trailer is added here to indicate that this is there. And here you get what? This is the whole frame where these blocks of data are transferred. In the case of asynchronous, the sender transmits the data character by character or byte by byte to the receiver at any point of time. In the case of synchronous transmission, there is lower overhead as there is no need to send start and stop bits for every single character. Whereas in asynchronous, it is simple as it does not call for synchronization between the sending and receiving devices, but it has a start and stop bits associated with the data. In the case of a synchronous, throughput is higher, but hardware required is expensive. In the case of asynchronous, hardware required for its setup is inexpensive as timing is not critical. In case of a synchronous, the sending and receiving devices must have a buffer area to assemble a block of data and is more complex. For error-free transmission, the clock of the receiving and sending devices must be synchronized. Whereas in the case of asynchronous transmission, it can be set up very fast and therefore very well suited for applications where messages are generated at irregular intervals like data entry from the keyboard. So it means what? Where it is suited in those type of communication where this data are generated at irregular intervals. It means what? For connecting input devices, printers, modems, fax machine, etc. There we can use the asynchronous transmission. Whereas synchronous transmission, this is suited for communication between two devices that have buffer to store the individual characters to form a data block of length 80 or 132 characters. Synchronous transmission is suitable for long distance data transfer, whereas asynchronous transmission is excellent for short distance. In case of synchronous transmission, data is transmitted fast in synchronized manner with fixed and constant timing intervals, whereas in the case of asynchronous, data transmission is slow at irregular and random time intervals. Synchronous transmission has a high efficiency it uses data blocks or bits without any gap between them. Therefore, it is used in video conferencing or live streaming. Whereas asynchronous transmission has a low efficiency due to wasted time between bytes or characters. And best example is the keyboard input, mouse input, serial data transfer. So in this particular lecture, we have seen the various transmission mode. Depending upon the direction of data flow, it may be simplex, half duplex and full duplex. Depending upon the number of bits that has been transmitted simultaneously, it may be categorized as a serial and parallel. And depending upon the clock, it is categorized as synchronous and the asynchronous. So this is all about the various transmission modes. Thank you.